Our next method is thermocouples. What do you mean by thermocouples? So this is also a device which is widely used to measure the temperature. That's why we are calling it as thermocouples. So usually it is consisting of two metal wires called A and B. So but which are of dissimilar. So dissimilar metal wires are insulated from each other but welded together so that it can form a junction. So we took two and we welded them. So there is a junction which is called as thermojunction. Thermojunction. Okay. So now we are going to keep a measuring instrument here to measure its temperature. Okay, so now this is how the thermojunction is arranged, and metal A and metal B were taken with which are not of a similar material. So this is based on the effect called Seebeck effect. That is, for example, if two wires of different metals are joined at one end, they were joined together, right, at one end, and we are connecting an instrument to make it as a complete circuit, which is called as an electrical circuit. Then the current flows in the circuit. When the junctions are kept at different temperatures, this circuit is caused by an EMF called thermoelectric EMF. So if temperature is also functioning, and the temperature difference of the two junctions means here and here, where we need to calculate the temperature. So this is going to have any particular pair of metals, means any metals when we are using, it is having two junctions. One is particular temperature which is not affected by the size of the conductor, and the other is where you are using an instrument. So according to this Seebeck effect, it is a phenomenon where the temperature differences between these two different conductors produce different voltage. So there is a voltage difference between these two substances, right? So the relation between this setup and the temperature difference of these junctions is given by an equation called E is equals to alpha T minus T naught plus beta T square minus T naught square. So where T is the absolute temperature of the system and T naught is the absolute temperature of the cold junction. So this is the hot junction and this is the cold junction, and alpha, beta are the constants. So where it depends upon the material you used. It means this metal is of some material, so alpha will change. B is of some different metal, so beta will change. Always alpha and beta are constants, which depends upon the value of this. So when these are connected like this, and when you are giving an input, obviously a hot junction will create some voltages, and the difference of these voltages will be calculated by this formula. It will give you the temperature value. This is how we are going to use a thermocouple. Okay, so usually what are the merits of this thermocouple? They are very rugged in construction, means the way we are constructing, it's very rugged. It's not easy, but it is capable of withstanding high voltages. Okay, so the thermocouples can be made very small sizes also, and they are very cheap, and its temperature can be until 1400 degrees centigrade, so high temperatures. So these thermocouples we can make with different kinds of materials, right? So we can use different kinds of materials which have pairs like from small 0.013 mm diameter also we can use. And we can use heavy gauge wires also. Heavy wires also we can use, small wires also you can use. It can give 1400 temperature. The price is less, sizes can be small and big, and construction of this can be withstanding high voltages. But the demerits of this is accuracy is not perfect. So as it is helping us to give minute miniature things also. The microvolts per degree of temperature will be not accurate. And always we should check these thermocouples whether they are working properly or not, because depending on the temperature or environmental temperatures around it also can affect our output. So always it should be made that when we are measuring these devices, we should be checking whether the value is accurate or not. That is the demerit. But coming to merits, it is helpful for high temperatures. We can do miniatures. We can go for high range values also.